What we want to achieve by the end of this series is to have a fully functional cloud-native application that can be deployed seamlessly across multiple clouds. Emphasis on the word seamlessly. This pattern is referred to as continuous integration and continuous deployment, or CI/CD for short. Having a fully automated process that takes care of testing, building and deploying new changes of an application with a simple code push and without service interruption, of course. We do this by following a DevOps approach, leveraging automation tools. There are two major tools that we will be heavily relying on: OpenShift pipelines using techzone and OpenShift GitOps using Argo CD. In addition to these, I'll be talking about the Cloud-Native Toolkit. Let's start with OpenShift pipelines. Techzone is a CI tool that allows you to define a workflow that can be executed in a number of different ways. This is a great way to automate your CI process and get your application up and running in a matter of minutes. Techzone is a Kubernetes native tool that comes pre-installed with OpenShift. We define Techzone workflows using YAML files, just like any Kubernetes resource. Technically speaking, Techzone runs pipelines that are composed of a set of reusable tasks. You can view the Techzone tasks as Lego blocks that you can easily plug and unplug to create new variants of a pipeline. Over to OpenShift GitOps with Argo CD. But first, I'd like to take some time and explain what GitOps is. We used to build what we call monolithic applications. This style essentially means one single codebase that has everything necessary to build and run the application. This is a great architecture style when making fast prototypes and MVPs, but it shows weakness at scale, and we will illustrate that with a small example. Let's say we have a monolith application that has a front-end and a back-end. If we need to change the front-end part, say you wanted to update the color of a button for instance, the back-end functionality will stay intact. However, the whole application has to be rebuilt and a new version will be released. And in changing the front-end code, you probably had to go through the back-end code and maybe fix a bug or two that appeared with the new updates. Back to the microservices pattern now. As said before, using microservices, the application is split into smaller codebases or services. This is a great way to make your application scalable and maintainable. What we also gain from this split is independence. Each service evolves independently and has its own lifecycle and versions. In our previous example, using a microservices configuration, we only need to update the front-end microservice and give it a new version. The backend will not be affected. Granted, the interfaces haven't changed. Now, this example is a bit too simple, but in reality, we will be dealing with multiple microservices, talking tens or hundreds or even thousands of microservices. How do we then manage versions and code changes of each service independently? This is where Git and GitOps shine. GitOps is a set of practices to manage infrastructure and application configurations using a Git repository as a single source of truth for declarative infrastructure. For application deployments, the GitOps repository acts as a blueprint to the application's structure, which services to be deployed using what versions. Please note that the GitOps repository doesn't hold the actual source code of the application. One tool that leverages the GitOps strategy is OpenShift GitOps or Argo CD. It is designed to propagate and run workloads automatically on Kubernetes and OpenShift environments. Using Argo CD, we can define where to run services, have different deployment environments, testing in production for instance, and Argo CD will periodically watch the GitOps repository and try to replicate what the configurations say. Lastly, the Cloud-Native Toolkit. This is a project created by the IBM Garage team that aims to provide a set of tools that can be installed automatically on any Kubernetes or OpenShift environment, thus making it easier to set up a consistent development environment in a matter of minutes. OpenShift is a secure platform by default, and the Cloud-Native Toolkit gives it an extra layer of security with additional software that tests and verifies code quality. The aim of the toolkit is to make it easier to set up a consistent developer story that can come in handy when you need to make showcases or demos using specific tools like Artifactory or SonarQube. These three tools will be the main pillars of our CI/CD process, and we will be using them to automatically build and deploy our applications in the next clips.